All right, today we're tackling something huge. We're going to try and piece together the biography of our home planet. And I don't just mean human history. I'm talking about the entire 4.5 billion year story of the rock right under our feet. So where do you even start with a story that old? I mean, there are no eyewitnesses, right? No diaries from the Earth's early days. How in the world can we know what its life has been like? Well, the answer, as it turns out, is a little unexpected. That's right. The story is kind of hidden in plain sight in the bibliographies of scientific papers. This long, dense list of citations, it's not just a boring list of sources. It's a paper trail. It's basically the diary of a scientific revolution that completely flipped our understanding of the world. And that whole story begins with just a few quiet whispers. Okay, so let's jump back in time to the early 20th century. Back then, most scientists figured the Earth was a done deal, a solid, static ball of rock that was just slowly cooling off, and as it shrank, it created mountains like wrinkles on an old apple. The story was basically over. But a few thinkers out there, they weren't so convinced. So you had these two completely opposite views. On one side, you have the establishment, a fixed, solid, unchanging Earth. And on the other, this totally radical new idea of a dynamic planet. A world with these powerful internal currents that could literally drag continents around and slam them into each other to build mountains. This wasn't just a new theory. For the time, it was pretty much geological heresy. The first real clues start showing up around 1931. A geologist named Arthur Holmes had this brilliant idea that radioactivity deep inside the Earth was acting like a giant engine, generating a ton of heat. He thought that heat could be enough to stir the planet's insides. And then, that same year, A.J. Bull connected the dots. He proposed that these convection currents Holmes was talking about, that could be the very force that builds mountains. These were the first real whispers of a planet that was in constant, slow-motion turmoil. Now, for decades, these ideas were way out on the fringe. But then, after World War II, we started mapping the ocean floor in detail for the first time, and a flood of new data started pouring in. And those whispers, they started to grow into a roar that would kick off a full-blown scientific revolution. The 1960s were just this incredible cascade of discovery. It happened so fast. First, you get the idea of seafloor spreading from Robert Dease. A few years later, scientists used some of the first computers to show that, the continents actually fit together like puzzle pieces almost perfectly. But the real smoking gun came in 1968. Maps of these magnetic stripes on the ocean floor. It was like a tape recording, proving that new crust was forming and pushing the old world apart. The evidence was just undeniable. And just like that, everything clicked. All these separate mysteries, earthquakes, volcanoes, the shape of the continents, how mountains formed, it was all explained by this one beautiful, powerful idea, plate tectonics. The Earth's surface wasn't a single solid shell at all. It was a mosaic of these giant plates all gliding around in constant motion. The whole revolution was really cemented by another huge paper in 1968. A team of seismologists, Isaacs, Oliver, and Sykes, took decades of earthquake data from all over the world and showed that the quakes weren't random. Not at all. They perfectly outlined the boundaries of these massive plates. This paper was the final piece of the puzzle. It pulled all the evidence together and basically turned the new global tectonics into scientific fact. So, okay, the big question was settled. The plates were moving. But how? What did the engine driving this whole incredible system actually look like? The next great challenge was to somehow see deep inside the planet and actually find those convection currents that Holmes had dreamed up decades earlier. And that is a huge problem, right? The mantle is thousands of kilometers thick. We can't even drill through the crust. So how on earth could we ever map a place that we can never, ever visit? The answer, it turns out, was to listen. Scientists figured out they could use the waves from earthquakes, which ripple all the way through the planet, to create a 3D picture of what's inside. Think of it like a medical CAT scan. A CAT scan uses X-rays to see inside your body. Seismic tomography uses earthquake waves to see inside the Earth. It's absolutely genius. And the picture that emerged was just breathtaking. For the very first time, we could actually see these giant, cold slabs of old ocean crust sinking like colossal waterfalls deep into the mantle. We could see hot plumes of rock rising up from the core, the things that feed volcanoes like the ones in Hawaii. And by the mid-80s, supercomputers got powerful enough to actually model this entire churning planetary engine in 3D. We could finally watch it work. But you know what? The story doesn't stop there. Because once we had this powerful new understanding of how our own planet works, we started looking out at our neighbors in the solar system, and we realized we finally had the key to start writing their biographies too. It's incredible when you think about it. Understanding Earth's engine allowed us to start decoding other worlds. We used the same models to figure out Venus's bizarre tectonics and to explain the giant volcanoes on Mars. We could even use them to figure out that Jupiter's moon Europa probably has a hidden subsurface ocean, all based on its magnetic field. Earth's story became the Rosetta Stone for the whole solar system. And the impact of this whole revolution? It was, well, seismic. As soon as plate tectonics was accepted in the 60s, you can see research just exploded. That early, quiet whisper became this massive, global scientific conversation, a cascade of discovery that just keeps picking up speed. Every single new paper that gets published adds another sentence, another paragraph, another little piece of the puzzle. That list of references just gets longer and longer every year. The biography of our planet is a living document, and we are constantly updating it as we learn more. From the deepest parts of the mantle to the icy moons way out past Jupiter, we are really just beginning to read this incredible story. And as that list of references keeps growing, the biggest question is still out there. What amazing secrets will the next chapter finally unlock?